entirely new.
Really? Green was supposed to get shit tons.
Charles was like,
This is in linear programming.
This heads up for the 8.
So for the guitar problem, how many variables do we have?
It's definitely solid range.
How many variables do we have? Three number of variables. I don't know if you did this in 395, but I always like to tell you what the capability of this software is. So this software can handle a model with up to 90 variables and up to 90 constraints. I have done models with all for Windows, literally 3 variables and 10 constraints model for a trucking company that saved them upwards of $1 million. Okay? So it is not the size or the capability of the software, but it is what you actually know, what you want to do, and whether you can do that is what the limiting factor is in terms of how you use these things. Okay, so 3 variables, and how many constraints? How many constraints do we have?
12.
Just give me one now.
12.
12 excluding non-negativity constraints. So, as you would know, as you would remember from your 395, linear programming assumes that the decision variables cannot take on negative values. Okay? But software such as Palm for Windows has already built that into the coding. So they don't need to specify those constraints, but you always want to remember that. So 3 variables and 12 constraints. Those who said 6 were only referring to resource constraints, but we have 6 other managerial constraints, or these are more or less 3 of them are marketing constraints and 3 of them are firm contracts with your customer constraints, right? Okay, so let's change the numbers here, or labels. Call this A, C, E. Maximize 100 times A plus 220 times C plus 300 times E. So let's talk about the resource constraints here. Cutting department. I'm going to label this as cutting. Then the next one is assembly. The third one is finishing. The fourth one is hardware. The fifth one is testing. The sixth one is packaging. Right? And then let's have those marketing constraints. So maximum demand for A, and I'm going to say minimum demand for A. So let's have the maximus. Max for C, max for E, min for A, min for C, and min for E. Okay, let's start putting some of these constraints down. Cuttings. Give me the numbers. 2 times A plus 3 times C plus 1 times E should be less than or equal to. Okay, give me the names, numbers. 800. Assembly. 3, 3, 1, 640. That's hardware, then no, finishing the testing. Hardware. Testing. Packaging. talk about maximum demand for A. Okay, so 1 times A should be less than or equal to 175. Then 1 times C should be less than or equal to 20. And 1 times E should be less than or equal to. Let's talk about the minimum that we have to produce of each of these. 1 times A should be, now we can toggle this and make it into greater than or equal to constraint. So A has to be at least 100. Oops, not 100. Then C has to be at least 25. And E has to be at least 7. Hopefully we have entered all this information correctly. Okay, so the objective is to maximize the objective function, solve. That's the answer. If you want to optimize the profit or maximize the profit from the production plan, then you will be producing 100 acoustic guitars, 30 classical, and then 80 of electric guitars. Okay, so if you look at the electric guitars, they are the most profitable guitars, right? So if this company had a very influential marketing function, what would they do? They would try to influence the allocation of the resources to making the most of E, correct? And it's the most profitable. In fact, it's not even profitable. Salespeople get paid on sales, right? They would not even worry about the sales revenue or profit from a product. They would try to maximize the sales of the products with the highest revenue potential, right? Remember the florist problem? If you put the objective function as maximizing revenue instead of maximizing the profits, it can give you a different answer. Okay? So that's the first thing. So when you are talking about managing a process that can process different types of customers or different types of products, it's no more about maximizing the throughput through the process. In fact, it's not even about producing the most of the most profitable products and so on and so forth, because those most profitable products actually could be cutting into all of your resources, and you are not left with any other resources to produce the other products that you have committed to your customers, correct? So these minimum requirements of those other products need to be produced. So it's not about just mindlessly trying to improve the throughput or focusing your attention on one type of customers. Okay? It is much more than that. So linear programming or linear programming models as an analytical method is probably the most integrative framework within which a manager can operate. That takes into account all the information about the processes that he's managing or she's managing from different perspectives, from the manufacturing perspective, which is reflected in the resource requirements, from the marketing perspective, which here is indicated by the upper ceiling on those products. And then if you really treat the lower ceilings on the products, they are firm commitments, which means they are the minimum demand that you must meet. So both those 6 constraints are really marketing types of constraints. You could actually have even more managerial preferences included or incorporated in managing such a process. For example, you might be you might want to say that you are a company that caters to all of these different types of products, or the customer base that wants each of these three types of products. So you could, in fact, as